Hello everybody, this is Mr. Cousage again, and we're up to the last section of chapter 2. So after this section, we'll review a little bit and take the test for chapter 2. Alright, 2-6 is nonlinear inequalities. Don't forget the date over here. So you know what inequality means. Greater than or less than, right? Not equal. So let's start by looking at a simple graph. Notice that in this graph, sometimes you're greater than 0 and sometimes you're less than 0, right? So at this point, you are equal to 0, right? But then to the left, you're greater than 0. From here to here, you're less than 0, greater than 0, less than 0, and then greater than 0 all the way up again. Another way to show this would be to put on a line your zeros, right? Your x-intercepts, which would be -4, -1, 3, 5, if you look. And then in between, you can tell with a plus or a minus if it's greater than 0 or less than 0, right? Greater than 0 would be positive, plus, less than 0. So this represents this. So we can write it this way, okay? Now, this is a representation, but we also have symbols to represent that. So take a minute and copy these on the left here, and then we're gonna, for this situation, we're gonna answer these questions. So this is some function, right? We don't have the polynomial, but it's some function, whatever that function is. So I'm asking you, when is the function equal to 0? Equal to 0. Well, that's the zeros. That's the x-intercepts. That would be -4, -1, 3, 5. So look how I wrote it. It's equal to 0 at these 4 places. When is it greater than 0? That means positive. That means above 0. So how would you write all the way to the left? So from -infinity all the way up to 4, it's greater than 0. And then not greater than 0, and this is greater than 0. From -1 to 3, but not including those, right? Because those are equal to 0. We want greater than 0 between here and here, and then from 5 onwards. Look how I did it. So -infinity all the way to -4, not including -4, that's greater than 0. And then we skip on to -1 to 3, right? That's above 0, not including -1 and 3, because that's equal to 0. And then from 5 onwards, from 5 to infinity, it's also greater than 0. What if we were looking for greater or equal to 0? Well, it's the same thing, except we include the 0, right? Greater or equal to 0. So from -infinity to -4, including -4, because we want to be greater than and also equal to. So we include -4. So -1 to 3, -1 to 3, but including -1 to 3, right? Including the end. Same thing here. We include. What about less than 0? Below. But there's only 2 places. Between here and here, between here and here, there it is. Not including, right? We don't want to be equal, so we don't include the endpoints. But if you do want to be equal to, then yeah, hard brackets, because you want to be equal to. Okay? So this is how we represent greater than or equal to. When we say greater or equal to, we're saying greater than 0, equal to 0, or less than 0. Right? Depending on what's asked. So to solve inequalities, this is how you do it. First, find the zeros, right? Find the zeros, because that's when it's going to switch to up or down. So you need to know where these points are. Those are the zeros. Then you test values in between, right? So take a value in between there and test it. If you get a positive answer, then you're up here. If you get a negative answer, then you're down here. Okay? And we can make a sign table, just like the one I had up there. Make a sign table to keep track of this. So let's see an example. And that's all I have, by the way, is this one example. And then we'll move on to part 2, and we'll do more in class. So here is something. Here is a function, right? Greater than -3. First, let's find the zeros. How do you do that? Well, set it, right? Set this to 0, and you get this, right? +3 +3. So this has to be greater than 0. I am asking, when is this function, the graph that goes up and down, when is it above? When is it greater than 0? Well, first, let's find out when it's equal to 0. Find out the zeros. So I factor that, and I find out, oh, x is equal to 0 at 9 and -3, right? So let me put this up. So that means something, it's changing here and here. So what I'm going to do now is figure out, am I positive or negative here? Am I positive or negative here? And am I positive or negative here? Now I know here I'm equal to 0, right? It's right on the x-axis. But how does the graph go in between? So why don't we just pick a number in between them? So on the side here, I decided to pick -4, 0, and 10. Okay? So you can pick any number here. I chose -4 because it was the smallest. Right? You can choose any number here. You can choose 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -2. Any number here. But I chose 0 because it's the easiest. Right? And then you can choose any number past here. I chose 10 because it's the smallest on this side here. Okay? So now, depending on if they give me positive or negative answer, I'll know if I'm above or below. So let's plug in -4 in here, shall we? What do we get with -4? We get 13. Right? If you trust me, if you plug in -4 here and do the math, you get positive 13. That means that in this section here, I'm positive. I'm above the line. How about this section here? Well, I chose 0 from there. So let me plug in 0, which is easy. 0 minus 0 is 0, minus 27 is -27. Right? Why didn't you write the answer, Mr. C? Because I don't care. I just care that it's negative or positive. I just care that it's below. Negative is below the line. How about 10? This side of the 9. Right? You can choose 11, you can choose 100, you can choose anything you want. I want to know, does it come out to positive or negative? Let's see. I plug it in, and I get positive. So 10 squared, so that'd be 100 minus 60 is 40. 40 minus 27 is still positive. So, I didn't have space to write the positive and negatives. I wrote it up here. So, I know now that the function is up here before -3, then it goes through -3, comes down here up to 9, and then goes back up. That's what I know. That's what I found out. The question is, when is it greater than 0? That's the question, and the answer is here and here. Can you write those answers? Well, negative infinity until -3, and then 9 to positive infinity. So here's the final answer. Our function is greater than 0, right? That's this function we're working with. It's greater than 0 at these places. -8 to -3, not including -3, 9 to infinity. And we use the union, remember that? Like always, they go together. Those two go together. I'm done. I have solved this. I have shown when this function is greater than 0. First, find the x's, and then test numbers in between to see if you're greater than or less than 0. And then pick the ones you want. By the way, if that would have said less than 0, then I would have taken this area here, right? From -3 to 9. But the question was greater than 0. If it said equal to 0, now I'm really going further than I need to. If it would have said equal to 0, then the answer would have been just -3 and +9. Done. Okay? All right. So see you later for part 2 under 11 minutes. That's pretty good. All right. Bye.